So, after tackling, handling, and successfully solving the Skewb, you decide that you want to expand your horizons a little bit and realize that there are other Skewbs that are out there but are of higher levels with that. I also wanted to briefly kind of define a little bit more of what a Skewb is, and a characteristic of a puzzle that makes it a Skewb is the fact that when you turn it, you're sort of bisecting the whole puzzle down the middle into two equal components. So if you can do that, then you've got yourself a Skewb. But what happens if you take a cubic form, 6-sided, and expand it out to a 12-sided dodecahedron shape? So you see one of these guys. Now it's a Skewb as well because a turn bisects it down the middle, as a Skewb will do. So it goes through the vertex. And it's really the same kind of puzzle. Now, I've actually already done this, so I'm kind of going a little bit retro. I did do a tutorial. My very first tutorial was on how to solve this guy. So I'm going to rehash that a little bit, but only for the purposes of sticking with our concept and sticking with our theme of correlating it with a previous puzzle and seeing if we can modify our strategies a little bit and even modify our algorithms or see the expanded effects of algorithms on a puzzle like this. So the first time you see a puzzle that maybe resembles in form or function a previous puzzle, try to correlate the structures with each other and the solve can be very similar. So in this case, when looking at it, when you expand this out to 4 layers or to a dodecahedron, you're basically taking the center and pulling it out. When you pull it out, you end up with this, and that's really what you have. So the center, as it's pulled out, kind of gives it a little bit of a nose here. You put more sides on it. And when you do that, whereas here, orientation didn't really mean anything, it could be oriented in any direction. It could be rotated in any direction. Here, that's not the case. It actually functions as kind of a super puzzle. A super puzzle or a supercube is when, whereas before it was one solid color, now it has colors on different sides, so orientation means something. This can't be rotated. So you correlate that and decide that, okay, I have to know how to rotate these pieces when I didn't have to rotate this. The other thing to keep in mind is that once you solve these smaller corners over here, these are pretty much going to be in place. Whereas in this one, these little corners here are just one part of it. There's other corners around as well, so you've expanded that also. So let's see if we can use the same strategies. The first thing that I would do is of course correlate the movements so that I can solve it very similarly. So if this shows it pretty well. So if this is a center here, this is then a center. So I'm going to correlate the movements like that. And I'm going to move it like this. So my crisscross pattern is going to go through this area here. So I can actually visualize that. I then simply correlate these corners here around the center with these corners over here. And then you pretty much have got it. Now the other thing that I'm curious about is how to affect rotation. So what I would do is I would just kind of experiment with what happens with the algorithm that I know in terms of what it does with the rotation. So I'm going to hold the green one here, green side in front of me with the blue side down, and I know that if I do my crisscross rotation, and whereas I define this as being counterclockwise and this is being clockwise, I'm going to do the same thing holding the middle here. This will be counterclockwise and this will be clockwise. So holding this in front of me and turning it like this, let's do a crisscross rotation to see what happens when I rotate this up. So down, down, up, up. Predictably, I notice this stays the same. These two are flipped. Now I'm going to flip it back and see what happens. So basically this blue one got flipped up here. So down, down, up, and up. So what I can see is that the first set flipped it up, second set flipped it back, but it also rotated it. So now I know that when I do that, it's going to rotate this by 180 degrees. So whereas before I had to move it twice to move it back, here I've got to do it 4 times. Because my suspicion is that I did it once, it rotated 180 degrees, or twice rather. I do it twice again, it'll put it back into the proper configuration. Turn, 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 flipped it up, do it again, turn, 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 turn. So we got it. we know what happened. We know that it flips at 180 degrees. We can also look to see the effects everywhere else. Notice that this got flipped, these guys got flipped, this got rotated. These two never changed. Actually, this whole side never changed. Just like what happened here, this whole side never changed. So the bottom part was not affected. In terms of rotation, let's see what happens. I know this is going to be rotated. Turn, 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 turn. Do it again. To rotate it back down. Turn, 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 turn. So now I see these two remain the same and everything else got rotated. So too, like with here, none of the bottom pieces got affected. Everything else got affected. So I know that during maybe a final solve, when I need to get things rotated back, if I do that algorithm twice, these two don't get affected. These guys all get turned. So if I wanted to turn it all back, I would need two that are in the right position, all the rest not in the right position. Oops, and then solve it like that, but I think I screwed it up. And no, we're good. So put that all in. So let's see how that affects our solve. Now again, I'm being pretty retro with this, but again, I wanted to explore this and do like a kind of making of so that you can see how our strategy changes when we go from a cubic form to dodecahedron form, correlating the different pieces with each other and knowing which ones have to have specific orientations. But the rest should be pretty much the same solve, save for the last corners, as we may have to be a little bit clever with that one. So, skadoosh. Fantastic. I always like seeing the dodecahedrons of multicolors scramble. It always looks so impressive and neat. So we're just going to apply the same strategy here. Let's start off with Old Faithful, start off with the green side here, and I'm going to put them in exactly the same way. The strategy has not changed. So I'm going to look for the green and the, what's that, brown? Sure, brown. Green and brown, aha. Green and brown, whoop. All right, so it's here. We have to get it rotated. I'm just going to stick with the algorithms just to kind of illustrate the point. So if I had to correlate it like this, I need to move this back from it. What I want to do actually is I want to rotate this here. So I'd like to rotate this in a counterclockwise manner. So I'm going to put this over here, and my rotations are going to be through this X. I'm going to hold my face down basically and rotate through that X and rotate in a counterclockwise. So maybe, hopefully you can visualize it. That's the whole thing when you have a dodecahedron. You have to skew your thinking a little bit so that you can visualize what's happening. So counterclockwise rotation is going to be this over here. So turn, turn, turn. You don't have to turn it back, it's already there. So green and white. Green and white, where are you? Green and white, right over here. So once again, we'll have to do the same thing. We're going to have to rotate this in a counterclockwise way. I'll just move it up here for simplicity. So counterclockwise, again, is going to be rotating from here. So turn, 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 and turn. So there it is there. Not too shabby. So far, so good. Blue and white, just can't catch a break, can we? So this has to rotate in a clockwise way. Yeah, clockwise. So I'll move this up here and start moving it clockwise. One, turn, turn, turn. Yeah, it's already in. Blue and brown. All right, same kind of thing here. This has to rotate counterclockwise. So we're going to do our counterclockwise rotation. Turn, 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 turn. So we have our first side. So it's okay to kind of turn the brain off and go on automatic once you've defined your algorithms. That way you don't have to pay attention to where every piece is. So the next step, just like with this, once I got a bottom, is to come up to the top and start putting things in the known position that happens with the algorithms. So for the sake of simplicity, I'm going to go to the top and see where I can move it in. And over here, I can move this down into here. Once I do that, I'm going to follow suit and see what goes opposite that. So turn, 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 turn. And it's not so simple this time because this is rotated. I have to keep the rotation in there. But I've already defined how to do that. I know that if I can go up and down and put it in right now. I don't have to, but I could. I can just go turn, 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 puts it up. I can do it again. Turn, 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 turn. So 2 brings it down, 4 rotates it. Then I'm going to see which one is supposed to go just opposite. And it looks like it's already here. So this is already here. So these are opposites. This, yeah, it's here. It's just rotated. It's just upside down. So now I could put this right side up if I want to do that. Just go up and down, up and down. Yeah, why not? Turn, 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 turn. That's 1. Put it back down. Turn, 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 turn. That's just to illustrate it really wasn't necessary to do that. So now I'm going to be pumping these guys back and forth, which will probably rotate it anyway. So what needs to go where? Well, this needs to go here, which means I got to flip these 2, which will flip these 2, and then I got to flip these 2. This pink and white will come down here. So no difference from the previous skewb. Turn, 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 turn. That's down but flipped. These have been flipped across. Doesn't matter. This will stay the same. I'm going to turn this around, flip these 2 in, and these 2 will come back by that algorithm. Turn, 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 turn. So all of these are actually in. This is in and rotated appropriately, in and rotated appropriately, in and rotated appropriately, in and flipped. This one is also in and also flipped. Because if this is flipped, yellow should be up here, which means this yellow should be up here. Now the next part is to deal with the problem of orientation, rotation. This is new for this particular puzzle, and we know the pattern that we have to do in order to make that happen. If I hold it here and start doing my turns here twice, I'm going to keep these the same, and I'm going to rotate these guys and these guys. So what I want is I want to position the puzzle to where I only have 2 that are in, so that I can, and the rest that are out, so that I can do the algorithm to make that happen. And this is the fun part of here, because it's not enough to know the algorithms, you have to look at the strategy. So let's see what we can do. I'm obviously going to have to do 1 move to set it up, and then or 2 moves, and then 1 to solve it. So what could I do? What configuration could I do where I only have 2 that are left in a solved state? If I hold it here and keep these down here, this stays solved, this stays non-solved, this gets rotated, this gets rotated, this gets rotated, and this gets rotated. Which means that this will be in and this will be in, but they're not right next to each other. So is there another way of doing it? Well, okay, why don't we try this? Because if I do it here, this will stay in appropriately, this will be scrambled, this will be rotated inappropriately. This will be scrambled, scrambled, and scrambled. So these 2 will be in, and I'll have what I want. So we're going to go ahead and do that algorithm twice here. Turn, 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 turn. Okay. Did it work? Yeah, this is still where it needs to be. I can tell this is appropriately turned because it matches here. So these 2 are right, and all the rest are wrong. This needs to rotate, this needs to rotate. So another turn of that should rotate these in the right position, and these will stay fixed. So we got turn, 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 bang, bang, zoom, pow. And look at that. We got them in. Beautiful. All these are in where it needs to be. That was the main challenge of this particular variation of the puzzle. Now these guys. Well, one thing about this is that all of these are by necessity. Whoops. There I go again. All these are by necessity in the right place. They're just rotated. So we could try to rotate these. This is still going to be out. So what I'm going to try to do first is put as many in as possible so I can isolate it to where there's just one center surrounded by those that are not in. So how about here? Well, this has to rotate. Now bear in mind, it used to be with this puzzle, we rotated it twice to move this down and up, and this moves and moves. This one we have to do 4 times, because if I rotate it twice, this will go switch and then switch, but it's going to be rotated. So now I have to do it 4 times. So I can go switch, switch, rotated, switch, switch, and then rotated back. So I have to figure out what 4 configuration of 4 will bring it back? 1, 2, 3, 4. Nope, green will be here. 1, 2, 3, 4, which makes sense. 2 divided by 4, 2, so 2. So over here. So I have to rotate this in a clockwise way. Will the same thing work here? 1, 2, 3, 4. Yeah. So if I do this, all of these should be in. And we're going to do that in a clockwise manner. But like in a clockwise manner like this. But we got to do it 4 times. So with these eyes looking at me, I'm going to do that 4 times. 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4. And that's in. Now notice these came in, but this was out, which means this was out of sync with these guys. That's okay. Now we just have these 2 left over, and we solve it exactly the same way. We've now completely reduced it to this, so it becomes easy. We have to put all of these in a rotated form. So I don't want to move it clockwise because that'll move this into here. 1, 2, 3, 4. I want to move it counterclockwise. So counterclockwise, we'll keep this out, move this out, keep this out, and move this out. So same thing in a counterclockwise fashion. 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, and 4. And that's exactly what we did. Now you can see that these 2 are in sync, so to speak. So we're not going to be able to rotate these in the same direction. Move it over here. And actually if I rotate this in a clockwise fashion, it'll put this in. Clockwise fashion will put this in as well. Because 1, 2, 3, 4. 1, 2, 3, 4. So this will be a puzzle solving maneuver at this point. In a clockwise fashion, we're going to do that again 4 times. 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, and you did it. You just expanded this concept into a super puzzle concept by learning what it does to your orientation, and you've managed to solve your kite skewb or rhombic dodecahedron skewb. Congratulations!